Hi there. Welcome to another chapter of the electric BMW 320i project. Hard to believe this is already video number 10. Thought I'd be driving the car by now, but still not. Still waiting on a couple critical parts. Still namely that spline adapter, but it's been machined and it's got the last final cuts going, so maybe next week it will show up. What I've been spending a lot of my time with is the last bit of engineering I had to do in the car, and that was the heater. I originally thought I was going to use a hot start like Jack uses, because then I could just plug it into the hot water lines that are already there and use all of the everything that normally is used with the hot water heating. Problem is, after I started putting everything in the engine bay and spacing out things and figuring out how they're going to be mounted, there's just no room for that hot start cylinder. It's quite large, just no room at all. So what I decided to do was to try out some PTC heating, and that's what I've been working with. And right here is the heater core of my BMW, which I took out. It's where the heater core resides, and then two big fans that blow the air to the various pieces. So I thought that maybe if I could put enough PTC wattage in there, I might be able to just use all of this fans and also all the venting and duct work, and wouldn't have to do anything else. But it's been quite a challenge just to get the PTC in this, as well as characterize them. So I'll show you that, as well as a few other things that have been going on with the car. Let's take a look. Here's a look at all the final wiring that's being done on the battery boxes. These now have all the wires for bringing, obviously, pack voltage and connecting all the batteries, as well as one lead for the battery heaters, the silicon pad heaters, and then another wire is going to be for the BMS to pick off a voltage and a temperature. And then obviously the wiring going back into the trunk, everything covered in the convoluted plastic. Nice way to protect the wires. Have another set of wires that are going to run up under the dash and go out through the firewall. So here's a look at the wires coming through the firewall. The white wires are Teflon cased wire. That's for the battery box heating, and then one wire for the DC, or sorry, the charger that will come out and charge the pack from this point. That's the motor mount for the Siemens, and then just been working on fixing everything up and figuring out where everything's going to get connected. So big hole in the dash is because took the heater core out, and I'm working on that now to put in change the old water heat exchanger heater core for one that's PCT based. And here's a look at how the mount for the DMOC is coming along. See, I had some modifications made, and just checking out the fit and everything for the cables. Looks like everything's going to work pretty good. So that's going to go out next week for hard anodization coating. Still haven't decided on the color yet, so I'll have to wait and see how it comes out. Okay, here's a heating test of one of the PTC heaters. I have the thermocouple and amp meter, and one sitting on the far end. It's just a weight to hold down the thermocouple on the surface. Now let's see how fast this sucker heats up. Now you can see it's drawn right up to 9 amps there, and temperature takes off, so that's like 10 seconds, 20, and you see, like PCT, it begins to self-limit the current. There, 30 seconds, it's at 90 degrees, 100, 50 seconds, it's at 120. It should, yeah, and it just shut off. There's a little thermostat on the side. See the current drop to 0 right at around 116 degrees C. So that's good. That's not too hot to cause any ignition, and it probably is just about right for the temperature that this this heating unit was regularly set for, because water in a car is typically about 200 degrees if it's under pressure. So that's well under that right there, 116, 120 degrees C. So these should work out really well. Now I'll test the heating speed with pretty significant airflow over the PTC. So it goes right up to 100 degrees C pretty fast. It's 20 seconds. It's interesting, we got to a lot higher temperature with the airflow. It should have cut out by now. It's at 170 on the surface. Some nice warm air blowing around. And there you go. It looks like with a good airflow, it's going to maintain 170 degrees on that surface. It's pretty warm. There, it finally opened up. Let's see how far it drops before it kicks back in. So there's the hysteresis, drops down to about 120, but it kicks on, it draws a lot more current. It'll be interesting to see how the fuse reacts to that. I think that'll work. Yeah, there it goes, 170 degrees. It's supposed to be a 160 degree thermostat, so I guess 10%. It's close enough. Here's something cool about this whole heater system. Just think about it. If you didn't have MOSFETs to be able to switch fan speeds or switch current, how would you do it? Well, what they did in this old BMW is they used a couple of big series resistors. So with 2 resistors you have 3-speed fan. You got no resistance, full speed, and then probably smaller resistor there, a little bit slower, and then the bigger resistor a little bit slower. So great way to do it when you have lots of DC current around because you got an alternator. But in an electric vehicle, it's probably not a good idea throwing away electrons to heat up resistors. So probably replace that little circuit with a MOSFET and use the input from the switch on the dash to switch the duty cycle to change the fan speed. Okay, here's the next process step, using the fans from the BMW, and see what kind of temperature you get on the PTC. So with the power supply, I only get the about half of the current going into the fans, so that's about half speed, but pretty significant airflow coming through. And I've got the PTC, 3 of them wired in parallel, so it's going to draw a pretty decent amount of current. This is Again, it's 3,000 watt unit. And the temperature as before, it climbs up very fast to 100 degrees C in just a few minutes, a few tens of seconds. But it does seem like it's going to work quite well. Putting on nice warm air. Same as when just powering up a single of the PCTs. On the same level, the air temperature is about 90 degrees. So the next step is to bolt it all together and see how it works. So here's what it looks like with the PTC mounted inside the heater core. So it just was like the perfect size, just barely fits inside that. What I did was I cut aluminum L bracket to the right size so it would fit, and then had it's a little bit not as deep as the original heater core, but that's good because it gives room for all these wires on the end. I also covered these tabs that hang over, which help hold the previous heater core in place with this material. It's a silicone foam rubber with an aluminum foil cover or sheet on the outside, good to 300 degrees C, and I'll show you that on the Big Master car. Really great material. I might actually put that in a couple other places. The only thing that's bad about this particular arrangement is you can see there's a fan here and there's a fan here, but there's no fan in the middle, and there's a PTC in the middle. So that's why you can see what I have now. I put the thermostat right in the middle, as well as I have a thermocouple on there now just for testing it. But it seems to be okay. Haven't seen it do anything too wild, but I'll be showing you in a little bit after I put this back together and fire it up. Alright, here I have the whole thing, heater core built up, fans all set up, the way they blow in, and the PTC inside all wired up, again just in parallel, and I have it running now for a few minutes, and air coming out is 63 degrees, so 43 degree increase in temperature is 20 degrees in this room, and you can see in parallel it draws a lot more current than it would in series, but it's the same amount of wattage going in. So the question is if that's going to be enough heat. I don't know what the air temperature of the original one was at, but it seems to sit here and oscillate. One of the thermostats on it is cycling, probably the center one, because I expect the center PTC is getting the hottest because it doesn't have a lot of airflow on it. You can see how this is set up. These two fans blow down and the center PTC is right in here, so contributes to heating but doesn't get a lot of airflow going on it. Still looks pretty good. Pretty consistent temperature. Now, it is interesting that if I slow the speed of the fan down, that was at half speed. That would be about quarter speed. You see the temperature rises. This is obviously that, and that's the air coming out. So, in other words, the airflow is overcoming the heat being produced by the PTC at the high airflow rate. So this would be one way you could probably keep the cabin really nice and warm, just flowing a little bit of air. PTCs will just cycle there on and off, and should be working well. So the last thing to do is, let's see, there's two holes, one in the front and one in the back. That's where the original heater core stuck out but didn't really do anything because it was rubber on the end of it, and just blocked the heat. So what I'm going to have to do is get some kind of insulation and block that up. Okay, so you can see a lot of fun adapting new things into old things, but I think it's going to work. Just have a little more adjustment to make, and placing that PTC in there, probably going to attach it some way so it doesn't rattle around. And but I think it's going to provide enough heat. Should help warm up the interior of the car or defrost the windshield, and at the same time, you know, was a good solution. I can get away with this because all the controls are just manual. They're just pull wires for changing the direction of the airflow, and there's a rotary switch, just a contact switch that the fan speed was set with. So that's the only thing I have left to do is build a little circuit to drive the fans, and I think I can get away with the MOSFET circuit and PWM that, because it only draws about 10 amps. 12 volts, and that would be probably too much airflow. I'm seeing here at 6 volts and 5 amps, it's plenty of airflow and plenty of heat being generated. So that'd be the last thing to do, and probably we'll put the whole circuit on a contactor, because it's going to have the pack voltage driving this, as well as I'll have an inline fuse. So hopefully next time, I keep saying this, I'll be in the car driving it, but at least now, because the weather's changed here, I'll at least have some heat when I am driving it. So thanks for watching, and we'll see you next time.